Okay, guys. Hello, welcome to today's lecture. We started chapter 5. We covered 5.1, 5.2, 5.3. We are on 5.4, and we're going to cover 5.5 today. So let's review a little bit what we learned so far. We learned about integrals in general. We learned that the limit of the sum of a function evaluated and a random representative on a subinterval times delta x, which was the length of the subinterval. I starts from 1 to n, and n goes to infinity, can be defined as the integral of function f of x d of x. We learned that in physics, we say that this integral represents the area. But in calculus, it can be anything. It can be just a pure calculation. Important formulas. We learned that if we have a constant function like k, the derivative of constant function is 0, and the integral of constant function is equal to k times x plus. This is called the constant of integration. If y is a power function, x to the n, we know that the derivative of x to the n is n, x to n minus 1, and the integral of x to the n dx is equal to x to n plus 1 divided by n plus 1 plus the constant of integration. We learned that if we have an exponential function like e to the x, the derivative of e to the x is e to the x. And the integral of e to the x with respect to variable x is e to the x plus the constant of integration. Let's see what else we learned. We saw that if we have y equals to 1 over x, the derivative of 1 over x, you can either apply quotient rule or say that, hey, this is x to negative 1, which is negative 1 over x squared. And the integral of 1 over x dx is defined as ln of absolute value of x plus constant of integration. If y is equal to sine of x, then the derivative of sine of x is cosine x. The integral of sine x dx is equal to minus cosine x plus constant of integration. Remember that we say that, okay, the derivative and integral, they are opposite of each other. So informally, we say that they cancel out each other. We also learned that y equals to cosine x has derivative negative sine x, and the integral, so antiderivative or of cosine x dx is equal to sine x plus c. more formulas for you. The integral of secant squared x dx is equal to tangent x plus constant of integration. So remember that when we have secant, the definition of secant of x is 1 over cosine of x. Suppose we want to prove this integral. Let us show that this equality is correct. So how are we going to do that? When you see a formula about integral, you can always take the derivative of left-hand side, take the derivative of right-hand side, and show that they're equal to each other. By taking the derivative of both sides. Okay. The derivative of integral, by using fundamental theorem of calculus, we know that the derivative and integral, they are opposite of each other and they cancel out each other. Is equal to the derivative of tangent x plus the derivative of the constant. So the derivative and the integral, they cancel out each other, and we get secant squared of x on the left-hand side. This is my left-hand side. Now take the derivative of tangent. Tangent is sine over cosine. The derivative of constant is always 0. To take the derivative of sine over cosine, we can use quotient rule. Remember quotient rule? If you have f divided by g, it is equal to f prime g minus f g prime divided by g squared. So we're going to use quotient rule. This is equal to the derivative of sine is cosine times your denominator, which is cosine, minus the derivative of cosine is minus sine, so you get minus sine times sine. The whole thing is divided by cosine x raised to the second power. Very well. On the numerator, you have minus, which is now plus cosine x times cosine x is going to be cosine x squared. Sine x times sine x is going to be sine x squared. Very well. You all know that cosine squared plus sine squared is equal to 1. This is trig identity divided by cosine x squared. So 1 divided by cosine is defined as secant. You have secant times secant, which is equal to secant of x raised to the second power. Left-hand side is secant squared, right-hand side is secant squared. They are equal to each other, so we just prove this formula. the proof is for practice. We're not going to prove all of the formulas, but this is a good practice for you to see left-hand side and right-hand side are equal to each other. So let us list important formulas on right-hand side for you. Then we go over examples together. So, formulas. The integral of secant squared of x is equal to tangent x plus constant of integration. The second formula is the integral of cosecant squared. Cosecant squared of x dx, which is minus, so let me put this using a different color, minus cotangent of x plus constant of integration. If you have secant tangent next to each other, if you have the product of secant x, tangent x, dx, this integral is equal to secant x plus constant of integration. If you have cosecant cotangent, the integral of cosecant cotangent is minus cosecant minus cosecant x plus constant of integration. Very well. If you have the integral of 1 over 1 plus x squared, this is equal to inverse tangent. Inverse tangent of x plus constant of integration. If you have the integral of 1 over square root of 1 minus x squared dx, it's equal to inverse sine of x plus constant of integration. So we are on 5.4, page 2. You can find these examples in the note. They are already posted on Canvas, PDF files. On Canvas. So the first example says, take the integral of x squared minus 2x plus 5 dx. To find this integral, you have x squared, then you have minus 2x, then you have a constant 5. What we're going to use, we're going to use the integral of x to the n dx, which is equal to x to n plus 1 divided by n plus 1 plus constant of integration. Very well. This is equal to the integral of x to the n dx minus 2 integral of x dx plus integral of 5 dx. You can write these in separated forms and just eventually add and subtract the outcomes. So here you have exponent 2. The first integral is x to 2 plus 1 divided by 2 plus 1 minus 2 times, exponent here is 1, x to 1 plus 1 divided by 1 plus 1, and the last integral plus 5 times x plus constant of integration. Remember that the integral of dx is equal to variable x. Okay, we're done with calculus part. The rest is algebra. Here you get x to the third divided by 3 minus 2x squared divided by 2 plus 5x plus c. Of course, we can cancel out 2 and 2. The outcome is equal to x cubed over 3 minus x squared plus 5x plus constant of integration. This is your integration. We are still on page 2. Second example. So this example says, hey, you have integral of 10 x to the 4 minus 2 times secant squared of x dx. What is this integral? Very well. First of all, I have 10 x to the 4. For this one, I'm going to use the integral of x to the n dx, which is equal to x to n plus 1 divided by n plus 1. For the second part, I already know that if I have secant squared, the integral is equal to tangent. I'm going to use this formula. Secant squared is tangent x. Very good. So let us start. The integral of 10 x to the 4 minus 2 secant squared of x dx is equal to. This integral, since it has a coefficient like 10, you can take this coefficient and write it in front of your integral. 10 times x to the 4 dx minus 2 integral of secant squared of x dx. Okay, I have exponent 4. I add 1 to it and divide by 4 plus 1. So I have 10 x to 4 plus 1 over 4 plus 1 minus 2 times, and I know that the integral of secant squared is nothing but tangent x plus the constant of integration. We're done with calculus part. Now we're just applying algebra to simplify this. 10 divided by 5 is 2. So the outcome is 2 x to the 5th power minus 2 times tangent x plus c. Let us move on to page 3. Another example for you. Page 3 of part 5.4. Here you have the integral cosine theta divided by sine squared theta d theta. Very well. I have cosine, and on the denominator, I have sine squared. Let's try to simplify this quotient expression, see if we can get anything similar to these integrals on the right-hand side. So this can be written as the integral cosine theta divided by sine squared theta is sine theta times sine theta. Very well. I know that cosine divided by sine by definition of trig functions is cotangent. So cosine divided by sine is cotangent of theta. I left with a sine theta on the denominator. So this is 1 divided by sine theta, sorry, this is theta, d theta. By definition, 1 over sine is cosecant. So this guy is the integral of cotangent theta, cosecant theta, d theta. Okay, let's see. Do I have that integral here on the right-hand side? I have the multiplication of cotangent and cosecant, cosecant, cotangent. The integral is minus cosecant plus constant of integration. This is minus cosecant theta plus constant of integration. So again, we are still on page 3. We're going to continue to the next example. There we go. This example says, evaluate this integral. This is a definite integral. X cubed minus 6x dx while your lower limit is 0 and your upper limit is equal to 3. Okay, perfect. So remember that fundamental theorem of calculus. Fundamental theorem of calculus says, if you have a continuous function, the integral of f of x dx, x ranges between a to b, is equal to the antiderivative of f, which is denoted by capital F, is f of b minus f of a. Very well. This function is a continuous function. You have a polynomial function, so you can write it this way. Since x cubed minus 6x is a continuous function, we can apply the fundamental theorem of calculus. So what are we going to do? We're going to find the integral, then plug in 3, then plug in 0, finding f of b and f of a, subtract them. So, integral 0 to 3 of x cubed minus 6x dx is equal to. The first term is x to the third, x to the n. So, it's going to be x to 3 plus 1 divided by 3 plus 1 minus, you have a coefficient, 6, you copy the coefficient. X has exponent 1, x raised to 1 plus 1 divided by 1 plus 1. Then we write the lower limit 0 and upper limit 3 here. The first term is x cubed plus 1, x to the 4, divided by 4, minus 6 divided by 2 is 3, so you get minus 3, x squared, and x ranges between 0 to 3. So what are we going to do? We're going to plug in 3, then we're going to plug in 0 and find the difference. This is equal to 3 to the 4 minus, divided by 4, minus 3 times 3 squared, minus, then we plug in 0. 0 to the 4 divided by 4 minus 3 times 0 squared. Well, look at this expression. It has 0 raised to 4, it has 0 raised to 2. This expression is always 0. So you don't have to worry about this number here because you know that this is just 0. For this expression, you get 3 times 3 times 3 times 3, 9 times 9, 81 over 4, minus 3 times 9, 27. Then we have to take common denominator between these two. You get 4. Let's write this up here. A little bit of space. 81 minus 88, which is negative 7, divided by 4. So this integral is equal to minus 7/4. This is 1/8. Thank you. 1/8 is not 88. So if we do the subtraction, we get 7, 27 over 4. Perfect. So we are on page 4 of the note. More examples. Page 4. So this example says here you have the definite integral 0 to 2 of 2x cubed minus 6x, 6 times x, plus 3 divided by x squared plus 1 dx. Okay, perfect. So, for the first term, you have to apply the integral of x to the n, which is x to n plus 1 over n plus 1. For the second term as well. For the third term, you're going to apply the inverse tangent. The integral of dx over 1 plus x squared is inverse tangent of x. Very well, let us start. Here we have the integral 0 to 2, 2x cubed minus 6x plus 3 divided by x squared plus 1 dx, which is equal to. So the first one is 2. The exponent is 3, so we add 1 to 3, x to 3 plus 1, divided by 3 plus 1, minus 6 times x to 1 plus 1, invisible exponent is 1, so 1 plus 1, divided by 1 plus 1, plus 3 times the integral of 1 over x squared plus 1 is inverse tangent of x. And note that your x ranges between 0 to 2. 0 to 2. Very good. Here you have 2 divided by 4, which is a fourth, a half. We get x to the 4 divided by 2 minus 6 divided by 2 is 3, 3x squared plus 3 times inverse tangent of x. And x ranges between 0 to 2. Fundamental theorem of calculus says that, okay, you just need to plug in 2, then plug in 0, do the subtraction. This is equal to 2 to the 4 divided by 2 minus 3 times 2 squared plus 3 times inverse tangent of 2. For this guy, we have to use a calculator. Minus, now we plug in 0. 0 to the 4 divided by 2 minus 3 times 0 squared plus 3 times inverse tangent of 0. Again, take a look at this expression. 0, 0, and inverse tangent of 0 is always 0. So this expression is 0. We just have to deal with this expression here. 2 to the 4, 16 divided by 2 minus 3 times 4 plus 3 times inverse tangent of 2. You get 8 minus 12 plus 3 inverse tangent of 2. 8 minus 12, negative 4 plus 3 times inverse tangent of 2. If you want to calculate inverse tangent of 2, you have to use your calculator. And the exam, we can leave it as it is. So this is inverse tangent. Next example is on page 4. Okay. Let's go here. Going over all details so you feel comfortable about taking the integrals. Well, here we have a radical function. So this example says evaluate the integral from 1 to 9. So you have a lower limit, you have an upper limit of function 2t squared to t squared plus t squared times square root of t minus 1. Everything is divided by t squared dt. Okay, there you go. When you have an expression like this, try to simplify it as much as you can. So, first, simplify your expression. This is the integral 1 to 9 2t squared divided by t squared. This is the common denominator, so we can divide each of these terms by t squared. 2t squared divided by t squared plus t squared square root of t divided by t squared minus 1 divided by t squared dt. Then simplify. So the first term has t squared and t squared. We can cancel them out. The second one has also t squared divided by t squared. The last term is 1 over t squared. Very good. So we made it very simple. It helps us to calculate the integral much more easier. So this is the integral 1 to 9, 2 plus square root of t, which is t raised to a half, minus 1 over t squared. If you flip this, you get t raised to minus 2 dt. Now, for each of these, I'm going to apply integral of x to the n dx, which is x n plus 1 over n plus 1. So let me erase this part of the board. So I write the rest of the details for you here. Okay. The integral of 2 is just going to be 2t plus. Now I'm going to take the integral of t raised to a half. I'm going to write it here. The integral of t to a half dt. Your exponent n is a half. We have to add 1 to it. You get t raised to a half plus 1 divided by a half plus 1. Okay, a half plus 1 is 3 over 2, 3 halves. So this is equal to t raised to 3 halves divided by 3 over 2. Well, you have 3 halves on the denominator. You can flip this and write it as 2 over 3 t raised to 3 halves. So this is 2t, and this guy, as we calculated that, on the other side of the board is 2/3 t raised to 3 halves. Now for the last term, t raised to minus 2. Here you have a negative exponent. The integral of t raised to minus 2 dt. Your n is negative 2. We add 1 to negative 2, so you get t raised to negative 2 plus 1 divided by negative 2 plus 1, which is equal to t to negative 1 over negative 1. If you simplify this, you get minus 1 over t. So the integral of t to negative 2 is minus 1 over t. You already have a negative sign in front of t to negative 2. Negative times negative gives you positive 1 over t. We have lower bound and upper bound. 1 to 9. Very well. Now we just have to plug in t, then we have to plug in 1, then do the algebra. The rest is just algebra. We're done, we're almost done with calculus stuff. So here you have 2 times 9 plus 2 over 3, 9 raised to 3 halves plus 1 over 9 minus, now we plug in 1, we get 2 times 1 plus 2/3, 1 raised to 3 halves plus 1 over 1. Perfect. This is equal to 18 plus 2/3 Okay, here 9 can be written as 3 raised to the second power. You can cancel out 2 and 2. You get 27. Plus 1 over 9 minus 2 plus 1 raised to any exponent is just 1. We get 2/3 plus 1. This is equal to 18 plus, can cancel out these two. 2 times 9, 18 plus 1 over 9 minus 3 plus 2/3. Very well. 18 plus 18, it gives you 36 plus 1 over 9 minus 3 minus 2/3. 33 minus 3, 36 minus 3 is 33. And you have 1 over 9 minus 6 over 9. So you get 36 minus 5 over 9. So the final answer, calculation here, it gives you, let's see, let's write down the rest of the things here for you. It's equal to 9 324 minus 5, which is 319 over 9. This is the final answer for you. It's 33, not 36. $292. $292. See, we all make mistakes. Thank you.